Let me see here. Bring in the LED. Drop it down.
You are gonna be a bad mother. What are your prime directives?
Make electronics easy. Keep it safe. Make it cool.
It's good. It's very good.
Hello folks, welcome to the channel today. My name's David with Terrain-Tronics, and hopefully by now you've seen this awesome build that John has done over at Tabletop Witchcraft. Here's some details of the electronics that go into that build and how you can copy it and make it your own. Now this epic build has a couple of features that we have to design for. On the top of the terrain there's a slow flashing LED, the kind of thing that you see on top of skyscrapers to avoid aircraft from hitting them. Down the side on the two pillars there are two LED strips that are mostly on, but one of them flickers occasionally. Behind the fan there should be a flickering LED. And then behind an access panel there's actually a bunch of LEDs that flicker randomly to look like they're sort of sparking or arcing inside. On the front there needs to be a small OLED display that flickers the status of the generator, and finally on top of the terrain there is a panel where you can slide in a smartphone to show a video of some kind. Now this video has been broken up into many sections, so you're going to find them time-stamped right down below.
I love that guy!
For this to work we need a brain, okay, and the brain used here is the Wemos D1 board. Easily available from Amazon and so on. It has a processor on board that we can program from a PC. In addition to that we have a Harlech board from Terrain-Tronics. This is what interfaces to all the LEDs we have in the product. It controls the flickering, the pattern for on and off, or just providing you the exact amount of current required to keep the same brightness. The OLED display in the product has an SSD 1306 controller in it, which is easily programmable from an Arduino environment. It has a resolution of 128 by 64 pixels, so it's not exactly high resolution, but for putting up warning signs and so on, it's perfect. In addition, there's a Wemos battery board that's used for charging and converting the power from the battery into something that the Wemos brain can use. To make the architecture work, we have to stack the boards so that they share the same power pins and communication can happen between them. To bring all of these boards together, we use these dual gender connectors. So they have a female connector at the top and then long pins underneath so that they connect to the board below them. At the bottom of the stack we have the Wemos D1 board, and then on top of that we use a Wemos battery board that's connected into it, and then finally the Harlech board goes on the top because all the LED wires are connected to it. All the external components like the OLED display and the LEDs can be connected using wire wrap technology. And so for instance the OLED display has 4 pins on the back which are ground, VCC, SCL and SDA, and these can be connected onto the dual gender connectors that we use to stack the boards to the pins which are marked ground, GND, 3.3, D1 and D2. Now you'll find the documentation in the GitHub to find out more about this. All the documentation, all the code, and even pre-compiled libraries and so on are all available on our GitHub page. Today we're going to download a pre-compiled file, which means you've got no need to do any programming at all, just download the file using the tools. Connecting your Wemos D1 Mini to your computer has been covered in this video right here. Now once you've ensured that you've actually got a connection and that it's coming up as a serial port, then download the tool that's in our GitHub. Now assuming you've followed the instructions on that former video to connect your Wemos D1 Mini to the board, then hopefully when you run the uploading app that we have, the custom one, if you go into port config you should see a USB serial CH340. That's actually the Wemos D1 board. So you're going to select it, click OK, and now it's been connected and opened. You're going to go to the next tab, firmware update, select custom because this is a custom image, and you're going to select the bin file that you've downloaded. Now that's this file here, and then upload. And it's going to double check with you, is this the bin file that you want to upload to an ESP8266? That's actually the chip that's on the Wemos D1 on COM port 10, and I'm going to click OK. If you have the OLED attached, then it should start giving you the information back. Now, if you like what you've seen today, comment, like, subscribe to the channel to stay tuned to the new products we have coming out, and to start a conversation with me on how you got along designing this product in. Then come along to the GitHub page. There you'll find the original code if you want to edit it. You can download a pre-compiled binary image, so you just download it to the product. We've even got a custom GUI that you can use to download those files and so on. And you'll find the design guide there with a shopping list, the hookup guide, another documentation for you to be able to clone this project or even make one of your own. I want to give a big thanks out to John at Tabletop Witchcraft. Without his inspiration and his ability to paint and so on, none of this would really come together. Thanks to all of you fans out there who are already subscribers or are following me on Instagram or on YouTube. We'll see you around. Please ask your questions below, and I really look forward to seeing what you manage to build as well. Take care.